Problem 2-9. This time we have the woman running to the river and her dog running back and forth between her and the river the entire time. Alright, so drawing a quick sketch of this, we got the woman who's running with a velocity of 2.5 meters per second down towards the river. And we have her dog. I only show him running this way, but remember, according to the problem, he runs back and forth and back and forth and back and forth. All right, but I just show him running this one way. His velocity is 4.5 meters per second. Now, the woman's going to run 4 kilometers at her rate. So that means that the amount of time that the dog runs is constrained by the amount of time that it takes the woman to get down to the river at her rate. Okay? So look in here. That's what I've written. Problem is similar to the bear and the tourist one in that in each case, the time is the same for each of them. All right, for each time is the same. In this case, constrained, as I said, by how long it takes the woman get to the river, knowing that the dog will run back and forth at his speed the entire time. All right, so taking a look again in general terms, we know that average velocity is equal to delta x over delta t. And rearranging, again, time, since time naught is equal to 0, we're just going to use t as the elapsed amount of time. And delta x over v, and again you can see I've dropped the over bar, the bar over the v, which indicates average, just because average and instantaneous velocity will be the same since it's a constant velocity. All right, so now t is equal to delta x over v. Is this true for the woman? Yes. For the dog? Yes. For anything. That's why I say in general terms this is going to be true for any constant v. All right, so for the woman, we just add the woman's subscripts. All right, t is equal to delta x for the woman over v for the woman. You can see same expression up here, just with the w subscripts indicating those values as indicated for the woman. And below that, t, the same t, is equal to delta x for the dog divided by the velocity for the dog. Again, exactly the same as I did up here, but with the subscripts indicating the delta x for the dog and the delta x for the, the velocity for, starting again, delta x for the dog and the velocity for the dog. Again, time equal to time, same time, so we just set these two expressions equal to each other. Delta x for the woman, a known quantity, divided by velocity for the woman, another known quantity, is equal to delta x for the dog, that's what we're trying to find, divided by the velocity of the dog. Scrolling down a little bit, we can solve for delta x for the dog, right? That's what we're looking for. And we can set that up by multiplying each side by velocity of the dog. Here, velocity of the dog times this expression here. I've just rearranged and sort of gathered things to show it's a ratio of their velocities, actually the inverse ratio of their velocities. All right, so delta x for the dog will be equal to velocity of the dog divided by velocity of the woman times the distance that the woman runs. All right, so plug in all that stuff in. As I said, those are all known quantities. Total delta x for the dog is equal to 4.5 meters per second, the velocity of the dog, divided by 2.5 meters per second, the velocity of the woman, multiplied by the distance that the woman ran, 4 kilometers. Okay? So notice again that units cancel out just like algebraic variables would be. So here we end up with a dimensionless ratio of 4.5 over 2.5, or 9/5, times 4 kilometers. 9/5 is 1.8 times 4, 7.2 kilometers is the total distance that the dog runs during the time that it takes the woman to get down to the river.